Hello and welcome to this refresher video on how to deal with the rules of exponents. Many times when we have numbers and they're being multiplied over and over and over again, the same number, for example 5 times 5 times 5 times 5 times 5 times 5, it's a little annoying to write this out over and over and over because it could be really long. So there's a shortcut way to write something like this, where we have 5 times 5 times 5 times 5 times 5 times 5. The shortcut way is just to write the number once and then use an exponent, a small number that represents how many times this number repeats. So 1, 2, 3, 4, 5, 6. Because there are 6 5s being multiplied together, we would say that this is 5 to the 6th power. The number 5 represents the base. The 6 is called the exponent, and this entire thing, when we put it together, the 5 and the 6, is called a power. And it's important that we discuss the rules of powers when we're dealing with this in mathematics so that we understand the shortcut in math. So let's take a look. For example, we could have x to the 3rd power, and we could ask you to write that out. Well, that's just 3 x's. X times x times x. Sometimes we're going to be doing math with these. For example, x to the 5th power times x to the 7th power. Now you could write these all out, but again, the whole purpose is if we write them all out, we're going to have writer's cramp. I'd have to write 5 x's, 5 x times x times x times x times x, and then times that by 7 x's. 1, 2, 3, 4, 5, 6, 7. And you can see that if you have to write all of these out, it could get really annoying. We would then count up all the x's. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And we get x to the 12th power. Now, there's some shortcuts, and that's what we want to talk about today. And I have those listed up here as the procedures of this lesson. So the rules for exponents are as follows. If you are multiplying 2 powers together, just like we did here in this problem, then you simply need to add the exponents. When multiplying powers, we add the exponents. So when we had x to the 5th times x to the 7th, well, that's just x to the 5 plus 7, which comes out to be x to the 12th. Other rules, when dividing powers, if we have x to the 15th divided by x to the 5th, well, here we're dividing powers. When we divide powers, we need to subtract the exponents. We'd be left with x to the 15 minus 5, which is 10. If you have a power raised to the power, so for example, x to the 7th, and we raise this entire thing to the 3rd power, so that's a power to a power, then we multiply the exponents. We get x to the 21st. The last procedure that we want to talk about when dealing with these types of problems are if you have negative exponents. Negative exponents are not allowed in mathematics. So for example, if I had x to the negative 4th power, that is not an acceptable solution in math. We have a rule that no negative exponents are allowed. No negative exponents allowed. It's like a sin in mathematics to write your answer like this. And so therefore, if you ever have negative exponents when you're dealing with exponents and their exponent rules, then you are going to need to flip this statement. In fact, the best way to think of it as if you have negative exponents, they move to the opposite location in the fraction and become positive. So we could think of this as a fraction, x to the negative 4th over 1. We could write this as these guys would come down and become positive. Or if they were already down, for example, if I had 1 over y to the negative 2, well, in this case, they would come up because they're already down. They would come to the top of the fraction and become positive. I sometimes like to think of this as the elevator rule. Elevator rule. If I could spell it. Elevator rule. Whenever you have negative exponents, you're allowed to ride the elevator, which takes you to the other location in the fraction, and then you become positive. Okay, so now that we've reviewed these 4 rules of exponents, it's time to let you give it a try. So go ahead and pause the video and work on these 7 problems. If you need help, make sure to look at our procedure box to see what rule of exponents you need to apply. Once you're done, go ahead and unpause the video and we'll see how you did. Okay, let's see if you got it. Let's work on it. Number 1, we have 3 to the 5th times 3 to the 11th. Now, whenever we're multiplying powers, you need to add the exponents. So this is going to be 3 to the 5 plus 11, which is 3 to the 16th. So we would have 16 3s if we were to write all of this out. But we don't want to do that. We're just going to write the answer as 3 to the 16th. Good. On number 2, we have x to the 8th over x squared. Ooh, so we're dividing powers. That's rule number 2 here. When you're dividing powers, we need to subtract the exponents. So it's x to the 8th, so it would be x to the 8th divided by x squared, and we subtract those exponents. So it would be 8 minus 2, which comes out to be 6. Great. Number 3, we have x to the negative 9th. Ooh. Now we learned that we're not allowed to have negative exponents. Anytime we have negative exponents, they move to the opposite location in the fraction. So this x to the negative 9th, we can't have that. It's going to elevate her down and become positive. 1 over x to the 9th would be the answer. Number 4, we have x to the 4th raised to the 5th. This is a power raised to a power. Uh-oh. When we have that, we need to multiply the exponents. It'd be x to the 20th power. Number 5, we have x to the 3rd times x to the 4th, all divided by x squared. Ooh. Let's work with just the top here. I get x to the 3rd times x to the 4th. We're multiplying powers, so we would add the exponents. That would be x to the 7th. Now we would need to divide it by x squared, which means we're going to subtract the powers. And so my final answer would be x to the 5th on that one. That was like a 2-step problem. Number 6, here we have negative exponents and we have some division. It doesn't really matter the order here that you do it. I'm going to go ahead and I'm going to think of this as division. I'm dividing powers. When I'm dividing powers, I need to subtract. So it would be negative 8 minus 2. So that's x to the negative 10 because it's minus 8 minus 2. Now we can't leave our answer like this because there's negative exponents. And so therefore I need to write my answer as 1 over x to the 10th. Notice it becomes a positive. Number 7, the last one, we have 5 to the 9th divided by 5 to the 3rd. Ooh, we're dividing exponents. When we divide exponents, we need to subtract these guys, the little numbers. So it would be 9 minus 3, which is 5 to the 6th. And that would be our answer. Notice that the bases don't change. Sometimes people want to change this 5. No. Bases always stay the same because we're dealing with exponents here. Okay, wonderful. Now that you've reviewed rule of exponents, you can move on to your next topic. Keep working hard.